Welcome to the Future of Fiber Reinforced Concrete conference call. My name is Richard, and I'll be your operator for today's call. At this time, all participants are in a listen-only mode. Later, we will conduct a question-and-answer session. Please note that this conference is being recorded. I would now like to turn the call over to Mr. Mike Mahoney. You may begin.
Thanks, Richard. Good afternoon, everybody. I want to welcome you all to the ASCC presentation on fiber reinforced concrete today. Again, my name is Mike Mahoney. I am a professional engineer working with the Euclid Chemical Company. I am also the current president of the Fiber Reinforced Concrete Association. The FRCA would like to take this opportunity to thank all of you and the ASCC for the opportunity to present portions of this program today. We will be discussing some items with regards to the current industry in fiber reinforced concrete. In short, the business industry, the business environment for fibers in today's concrete world is good. There are new materials, new projects being used. Fibers are becoming more widely accepted through the architectural and engineering community. There are new materials, design, codes, applications which are allowing value to be brought forward in the reinforced concrete community. Part of this presentation today will focus on understanding the differences between the various materials in the use of fiber reinforced concrete. We will discuss a little bit of the economic advantages and a few of the new codes and standards specifically to the contractors community and how the information that's available can help you feel comfortable with using fibers. And then to finish off, we will go over some projects and talk about some of the common issues, myths, concerns, some of the items that might be related to not using fiber reinforced concrete, or perhaps some of the history that is used by contractors with regard to older technologies or older ideas. Basically, this is a state-of-the-art presentation on the current use of fiber reinforced concrete as it stands today as an industry. With any fiber presentation, you do see a slide on history, and we're not going to spend a lot of time today discussing it, but I think it is important to know that for contractors, ready-mix producers, owners, architects, engineers, fiber reinforced concrete is not new. It has been around for many years. You can go back in documented history with straw and mud bricks, pioneer construction, stucco building. Fibers are common. They are used in a lot of concrete, but there's a lot of room for them to grow. And as we move forward, we have to understand why they were used and why we continue to use them. The short answer to the use of fibers is that we use them to control cracking. Concrete is a brittle material by nature, and we place rebar and other materials to change the characteristics, specifically in the hardened state, of how concrete behaves. Whether the fibers have different shapes, flavors, sizes, colors, it really comes down to different fibers for different applications, and it's important to know that the type of cracking, temperature shrinkage, drying, structural, thermal, that there are different fibers for different uses. Over the past 10 years, the use of fiber reinforced concrete has advanced substantially, and through other technical organizations such as the American Concrete Institute, the Precast Association, the Steel Deck Institute, we now see a lot of definitions for the use of those fibers. There are specific definitions even to the material types, such as microsynthetics and macrosynthetics. If there is one item that you do take away from this presentation today, is that the fiber industry is changing, and it is centered around some of these new definitions, specifically the microfibers, which many contractors, ready-mix producers, and engineers would recognize as the short hair fibers, small fibers, 1 pound per cubic yard type fibers, and then the macro fibers, which is more for the steel fibers, the larger synthetics, the toothpick-shaped fibers that are now being used to replace steel. The fiber industry itself has spent a lot of money. They've spent a lot of time. They've provided a lot of research. And now we're seeing, and you will see in this presentation today, some of the projects that fibers are now being used on. and these are national companies, major design firms, all who are now accepting fibers for various reasons, including ease of construction, safety, value. Some of the projects that you will see and some of the things we will talk about today include the fact that macro fibers can be used per building code definitions to be used in composite steel deck construction. Some of these fibers are also UL certified, meaning that they can replace the steel in a composite deck and carry a fire-resistant rating up to 2 hours. Other projects you see in the industry now that you did not see about 10 years ago include the use of fibers for swimming pools, for residential construction, precast products like lawn crypts and septic tanks. And you get back to the definitions, there are documents within ACI that are now permitting the use of macrosynthetics and steel fibers to be used with the same design components as steel for reinforced concrete floors. And we'll cover some of that material as we go forward today. Our industry is very slow to react. I think that is well understood, but what is unique over the last 5 years, especially as our industry has come out of a recession, is that the engineering community, the architectural community, the design community are now looking for value. They're looking to make structures last longer. Specifications are getting tighter. Construction schedules are getting more difficult to follow. And it pushes a lot of the burden onto the contractors and the ready-mix producers to look at new technologies and new applications. When it comes to the use of these newer fiber materials, that sometimes may be very difficult, especially when those products are not in the books that are on the shelves of the designers. What we want to get into for the contractor is looking at the use of reinforcing, but not physically on the ground, but in the concrete supplier's truck, and equating that to a value equation. As a contractor, if you're able to save time and money on a construction project, that should be a benefit. If safety is a concern, or placing steel on a composite deck where rolls are used, the use of chairs, if the designer is requiring certified equations or test data, that information is now available. And as we move forward as an industry, the fiber industry, with the codes that are coming forward, the ACI definitions, and 10 years of successful track record with macrosynthetics, 30 years of steel fibers, and 40-some plus years of microsynthetic fibers, there is now enough information out there that there should be a high level of confidence with the use of fibers in concrete construction. As I move forward through this presentation, I will be throwing some terms out, and I want to ensure that everybody on this particular call understands what the definitions are between specifically microfibers and macrofibers. Microfibers, again, are the traditional plastic shrinkage protection. Some people will refer to them as secondary reinforcing, but these are the small fibers that are typically dosed at 1 to 1.5 pounds per cubic yard. When you look at macrofibers, some of the marketing folks have called these structural fibers over the years. These are engineered dose fibers that can be used to be an alternative material to steel, but typically the dosage rates will vary significantly. With steel fibers, anywhere between 15 to greater than 100 pounds per cubic yard in concrete, and in the macrosynthetics, 3 to 10 from a commercial standpoint, with dosages going as high as 20 pounds per cubic yard in some specialty applications. Again, over the past 10 years, our industry is now accepting, and by the industry I'm referring to the ready-mix concrete folks, the engineering community, the architectural community. We're now defining microsynthetics, again, plastic shrinkage protection, and macrofibers, steel fibers, industrial floor design, pavements, warehouses, hangars, bridge decks. The steel fibers and the synthetic macrofibers kind of in a class by themselves, something different, a steel alternative, usually heavy requirements on engineering calculations to provide accurate dosage rates. Both materials have their place, and both materials are growing very quickly within the industry. From an application standpoint, this is falling in line with some of the material you've already seen. The use of microfibers, again at 1 to 1.5 pounds per yard. You can make an argument that some of these fibers might go as far as controlling some temperature and shrinkage cracking for light welded wire reinforcing. But if you wish to replace steel, and I'm going to focus a little bit on that later in this presentation, you do need to convert or upgrade to the macrosynthetics and the steel fiber products. The strategies that you would use as a contractor right now really start off with educating yourself on these products. They will provide a more economical and safe reinforcing alternative to conventional wire fabric and temperature steel. With the design tools and the test data that's available, these products can add value to a project, and that basically equates to a cost saving. The value can also be brought in for safety, and if you talk to your various fiber manufacturers, there are 20-some manufacturers of fibers within the United States alone, all carrying 5 to 10 different fiber types. They will provide training and help you work through, develop specific marketing plans, promote to your local engineers, your architects, on where you can and cannot and should use fiber reinforced concrete. If this hasn't been made clear to this point, I would hope that the number one reason why you would use fibers is simply just to save time and money. That's really what we're looking for. But the use of fibers does give you better concrete. And quite simply put, better concrete should give you less callbacks, less repair, longer lasting structures, more durable concrete. As the papers, and there have been over 10,000 published articles on the use of fiber reinforcement over the various years, we now have the ability to show how much fiber you need, and the engineering community, through documents like ACI 360, are accepting these materials as an alternate to fiber reinforced conventional reinforced concrete. For the general contractor and the ready-mix community, the value, the acceptance, and the profits are now they are now driving our industry forward. And so the value and safety equation, no matter whether you want to look at the technical aspects of fiber, the various pricing, if you're able to show value and safety, that should be a win-win for the supplier, the contractor, and the owner. One other item to point out is also quality of construction. If wire fabric or rebar is not placed correctly, where does the liability fall? Now, this can be a touchy subject, but when you do use fiber reinforced concrete, because the fibers are three-dimensionally distributed throughout the mix, you are generally getting what you're asking for. If you need an equivalent to a wire mesh and a fiber manufacturer provides you a set dosage rate, that dosage rate has typically been calculated to provide an equivalent reinforcing option to where the wire was designed to be in the first place. And again, safety and value can come into the equation at a later date. As mentioned before, there are a significant number of fiber manufacturers within the industry. If you do need more information, they are perfectly willing to help you. The majority of these companies do have engineers on staff. They will do lunch and learn seminars. They will come talk to the contractor. They will go talk to the ready-mix producer, the owners, and the engineers on your behalf. And a large number of these organizations and companies are participating at ACI, at ASCC, through various other trade organizations to push the industry forward. From the contractor's perspective, these are, I hope, some of the questions that you would be asking leading into a seminar on fiber reinforced concrete. Where is it being used? What codes can I use? How do I hang my hat on a design where fiber reinforced concrete is specified and I'm not going to get in trouble? Will the engineer specify it? Where do I buy it? How do I finish it? What does it cost? These are all the typical questions that I would hear from a contractor when beginning to offer fibers as a solution to a particular project. Not to get into heavy technical details, but this one slide is essentially a single slide snapshot of what many fiber manufacturers use to calculate the appropriate amount of macro fibers in a concrete mix, whether it be for shrinkage, whether it be for moment design, flexural capacity, plastic shrinkage protection. Again, all of these pieces of information and the test standards that are associated with these have really evolved over the last 10 years to the point that we now have a very good understanding of how fibers work in concrete and, again, what value they can provide to a concrete contractor or an owner. To go beyond the simple equations, some companies are now also promoting the use of structural design. ACI 360, which is a very good document for the contractors community, has within Chapter 11 a section written for the use of fiber-reinforced concrete, and it discusses macrosynthetics, steel, and microsynthetics, whereby instead of replacing steel, you can now design a floor from scratch as long as you have information pertaining to the subgrade modulus, the wheel loads, the spacing of the joints, the temperature, the flexural strength, all of the information that the engineer used to design a conventionally reinforced floor, we can now do with fiber-reinforced concrete. So again, just another tool that's been developed over the last few years with regards to putting fibers in concrete. One of the other questions that I didn't hear you ask was cost. It would not make sense in today's environment for you to use fiber-reinforced concrete if it did cost more than conventional steel. One of the items you do need to be conscious of is not all fibers are the same. So if you are looking for a performance-based solution, not necessarily a price per pound from your ready-mix supplier, take a look at the amount of fiber, the adjustments to the concrete mix design, and compare that to your conventional steel project, which would include the cost and transportation, the installation, possibly inspection, waste, and the common denominator through both of these projects would be the square footage. Concrete with fiber generally comes in a cost per cubic yard. Your steel is at a cost per square foot. If you can put those two programs together, and every market will be different in every corner of the U.S., you should see that today's market for fibers, again, will offer a cost savings on a project-by-project basis. One of the other questions that typically does come up during these conversations with especially the engineering and architectural community is the spacing of joints when using fiber-reinforced concrete. Currently, our industry is doing research, development, testing, and in-place applications to go beyond what is currently recommended in ACI. As an example, an 8-inch slab that would require 19 feet of joint spacing. The fiber community is working with various contractors and is doing some work within universities to see just how far we can place that. Can we go to 50 feet, 60 feet, 100 feet, jointless? There are a lot of other factors that come into play when you want to increase joint spacing, including the subgrade, the quality of the mix design, how that slab is going to be cured. However, this is a new frontier for the fiber industry, and hopefully over the next few years you will see more information on what we can do with combined admixtures and various types of fibers to make better lasting concrete so that we do not see joints in pavements and in floors. Another application for value, as discussed earlier, is a change that will be implemented into the building code. This document from the Steel Deck Institute in regards to the use of temperature and shrinkage reinforcing for composite steel deck design, going forward, this document has been accepted into the building code and will be published in 2015. And as you can see on the left side of the screen, the use of a minimum of 25 pounds per cubic yard of steel fibers or a minimum of 4 pounds per cubic yard of macrosynthetics may be used to replace temperature and shrinkage steel for composite steel deck construction. Again, a cost savings a safety savings and a time saving on a project. For those contractors that are currently doing this, there is good testament and good field applications of where this is working. Some of these companies have also gone out, as I mentioned before, and have acquired a UL rating on these fiber systems. The photo on the top left shows what we're talking about in terms of safety, where there is no steel or wire to move over, and the use of the UL rating will now permit these types of applications for fibers to be used in schools, hospitals, government, mixed use, bank buildings, and general residential construction. Some of the other items that I wanted to cover with regards to the use of fibers, and although there are some theories on what is correct and what is incorrect, some of the things you may need to be aware of when using higher volumes of steel and macrosynthetics is when you are saw cutting the joints, you may need to cut slightly deeper to allow for those joints to activate. If you can imagine, a saw cut joint with fibers across it, especially for high volume, is basically like stitching concrete together. Extremely high volumes of fiber may actually cause a crack where fibers are present to be stronger than the surrounding concrete. Also, when you are broom finishing fiber reinforced concrete, a typical concern that comes up from many contractors is that you see fibers present on the surface. Some of the things to alleviate and not necessarily eliminate is to ensure that you do single pass, low angle, use clean equipment, and watch the timing of your finishing. Fibers in general do not alter the setting times of concrete. Although the mixture does appear to be stiffer, you should still apply your finishing techniques at the same times that you would apply to normal concretes. Other items that would apply if you are applying a shake hardener onto a floor. Because fiber reinforced concretes generally delay bleed water, again, maybe slightly controversial, but fibers do make a concrete mixture more homogeneous, and as such, bleed water may be slightly delayed. Again, timing operations do need to be closely monitored to allow for the bleed water to come through that concrete and then be able to have your application for your shake hardener. Some of the other subjects worth discussing this afternoon include how to mix, place, and finish fiber reinforced concrete. When it comes to the macrosynthetics, there are some concerns within the industry of how someone can place 5, 6, 7 pounds of macros or 50 to 60 to 70 pounds of steel fibers. In reality, these mixtures still behave the same as microsynthetics in that you do have to account for slump loss, you may possibly have to alter the mix design, and you may have to pay more attention to how those mixtures are finished in the field. As a contractor, when you see slump loss, your first indication is typically to put more plasticizer, more water reducer, or water if it's necessary. However, water should not be used when using fiber reinforced concrete because that will alter other properties, including possibly lowering the strength. As another general rule of thumb, when a concrete producer is supplying macrosynthetic fibers, you can expect an inch of slump possibly for every 2 pounds of fiber or for every 15 pounds of steel fibers. For projects that are requiring high volumes of fiber, such as 5 pounds of macrosynthetics or 40 pounds of steel fiber, you can have significant slump loss, which does need to be accounted for in the mix design. Your concrete producer needs to be aware of this, and they need to provide you with something that can still be placed or pumped and finished with ease. With regards to placing and finishing, in general, fiber-reinforced concrete mixes can be placed just as easily as conventional concrete. There is argument to be made that it may even be able to be placed quicker as there would be no steel or chairs to move around. FRC is ideally suited to mass placement, large concrete areas where you do have tight construction schedules, and the use of finishing operations that need to get onto slabs quickly. Some of the other facts versus myths that I do see and have to answer for within the industry is the use of fibers changing compressive or flexural strength. That is not necessarily an accurate statement. There is data and some research that shows that slight increases in strength can occur. That has a lot to do with how the concrete mixtures are properly consolidated and it's more homogeneous. But in general, as an engineer, I would design my strength around my water-cement ratio. In terms of fibers balling, seeing watermelons and baseballs and footballs rolling off the back of a concrete chute, there are no fibers within the industry that do not possibly ball up in concrete. But the key to those is to work with your ready-mix producers. If fibers are to be used, how they add those fibers, where they add those fibers is extremely important. And the three most important words that will go a long way to alleviating those potential problems would be simply a pre-job meeting. Discuss that with your producer, that fibers will be used. Ensure that they're not allowing the slump of that mix to go below 2 inch at any time during the batch sequence when adding fibers or admixtures. And have that concrete delivered on site with the fibers properly distributed within the concrete. Some of the other items, too, that occur with regards to myths include the use of trying to pump fiber-reinforced concrete. And it really is a myth with regards to the fact that long-length fibers cannot be pumped. Many successful applications have pumped steel fibers and macrosynthetic fibers over significant distances. There are, again, some tips and tricks to the successful use of fiber-reinforced concrete in pump applications. The first item being, of course, the mix design needs to be pumpable on its own. We do not want to see mixtures overwatered for the slump loss. Essentially what that's going to do is potentially segregate your mix through the line, squeezing the juice out of the concrete and basically leaving a fiber clog or a ball. Some of the other things, too, for your ready-mix producers is to ensure, as shown in the top right photo, that they do not rest the concrete truck chute directly on the grate. Allow that fiber concrete to impact the grate, and the energy, which is the same as vibrating the concrete, will help that mix pass through. If the slats are very close together, or if they are rectangular, there is the potential for fibers to bridge on those grates. However, if you can provide round slats or vibration, in general, you should have a successful FRC pump project. There's lots of other items, and for the sake of time, as we finish up, I didn't want to talk about all the other advantages that fiber concrete does, but in terms of marketing yourself as a contractor, as a quality concrete contractor, to what else fiber-reinforced concrete can do, there's a lot of things that you can talk about and a lot of papers that will back this up and a lot of information your fiber producers can provide to you with regards to increasing, simply put, concrete quality. Again, getting back to making better concrete means less callbacks for you. So to finish up, what I would like to do is show you where some projects are being used. In effect, fibers are not just for sidewalks and driveways anymore. Fibers are being used on significant large projects, such as the one in the photograph, where you can see macrosynthetics to replace number 5 rebar on a 10-inch concrete slab with the application of a dry shake in the center of the photo of the laser screed application, all the way down to all of the finishing techniques and the proper application of a cure and seal onto a concrete slab that has the quality of a dance floor. You look at the use of self-consolidating concrete for decorative work, wall construction, precast concrete. You combine that with self-consolidating concrete, safety, insurance, again, value. The use of fibers in bridges and roads, or as I would like to call it, corrosion-free wear surfaces. Fibers bring a lot of value, and again, the architectural and the DOT and engineering community are beginning to accept the use of fibers in their pavements. And in fact, if you look at some state specifications, if we have anybody from the state of Illinois, IDOT is now allowing the use of fibers for white topping projects. And again, they have recognized and have written a performance-based specification that allows the use of fibers to replace conventional reinforcing to provide value and speed of construction on paving projects. In regards to pavements, this is a case study that I was particularly involved with in 2005, where 5.5 pounds of macrofiber was used for road construction to replace a road mesh. And in the year 2013, I revisited that site 8 years later, where there is no delamination, no joint deterioration, and no cracking in this slab. In effect, this corrosion-free pavement looks identical today to the day that it was poured, and again bringing value to the owner who does not want to have to put together maintenance programs. He understands that by switching from steel to fibers, we now have a situation where the value of his concrete is going to be substantially lengthened in terms of life cycle. Some of the other projects that you typically see now using fibers include distribution centers, polished floors. The contractor community well recognizes that you can do a lot more with concrete today, even when it comes to things such as colored concrete, stamped, broom finished, stained concrete, decorative concrete. All of these projects, again, are bringing contractors to the forefront and recognizing that they can do not just, again, sidewalks and driveways, but large convention centers, retention linings, canal linings, again, with no steel to replace, speed of construction, significant value improvement. Projects such as the photograph in the bottom middle of the slide show rehabilitation work where rolls of steel were not able to be brought on to a project where new floors were being built for an inner city development and replacement of an existing factory and conversion into a condo development. Fiber reinforced was pre-installed into the ready-mix truck and pumped up onto the floor. Other values for those of you who are in the shotcrete industry, spraying the fiber within the shotcrete mix, again, safety and value. And to take this to kind of a larger scale, these are two significant projects here in the U.S. which some of you should recognize. All of the flat work on these two projects does contain macro fibers. Every piece of horizontal concrete was reinforced with macro fibers. And some of the major architectural firms are now specifying fibers in a lot of other projects, again, because they want these projects to last. No cracks means better concrete. You can go from the big projects all the way back down to the small projects. Walls, footers, residential construction, small retaining walls. Again, these are applications where fiber reinforced concrete has been engineered, designed to replace steel. We can even go from commercial type to decorative, as mentioned before, architectural precast, decorative concrete, specialty projects such as the Atlanta Botanical Gardens fiber reinforced concrete walkway, polished concrete. For those folks that do not believe that fiber reinforced concrete can be polished, I would welcome you to go visit the Erie Art Museum in Pennsylvania. Typically, though, for macro fibers, and I believe this was a high-volume macrosynthetic fiber dosage, you would need to apply a deeper grind if you wish to have polished concrete. A light grind will most likely expose some fibers that may lay flat at the surface, and they would appear as small lines or streaks. A deep grind, pushing through that top layer of paste, will provide you with the quality of concrete floor that you would be looking for and could achieve even with conventional concrete. If you are interested in trying fiber reinforced concrete for your next project, I would recommend you contact your fiber manufacturers. Most of them are willing to donate materials to help you through a project, a demonstration project. They would be able to connect you with some higher-end researchers, but at the same time, you would be able to show that you are able to do something unique. And with regards to where we are headed, I've talked about where we've come from, but our industry is, as mentioned, looking at combining fibers and admixtures to increase joint spacing. We're looking at the transfer of load across joints. What is the effect of fibers on long-term performance of saw-cut joints? The short answer is the current research is giving very positive indications that we will get better concrete again. We are looking at issues with regards to sustainability. Whether you're on one side of the fence or another, there are engineers and architects who are requiring sustainable attributes in their concrete. Fiber-reinforced concrete can provide positive sustainability attributes. I have mentioned the composite steel deck code approval. You will see new fibers. You will see fibers used in other products. And as I have done before with producers on the ready-mix side, whether you believe in the use of fibers or not, they are coming. And the use of fibers is growing. There are a lot of opinions on these products, even from mixing to finishing, but it is true that fiber-reinforced concrete works, and we can say very easily that it's cheaper, faster, safer, greener. So as our specs and our documents become more and more involved, I would challenge anybody who does have additional questions to look through ACI, to contact ASCC, and get some more information. The ACI, this is not an endorsement, but it's just to make you aware, they do have an e-learning module on fiber-reinforced concrete, which is available now at concrete.org. In conclusion, I want to thank you all for your attention today. Again, look for those opportunities. I think from the contractor's perspective, value, safety, speed of construction schedule would most likely be the logical avenue to start a discussion on fiber-reinforced concrete. If you wish to brand your mixtures, I think that would make an easy value-add sell to your customer base. And again, the fiber community that's out there, the suppliers, the salespeople, the engineers that work for these companies, will help you work with owners and the A&E community by putting on lunch and learn seminars and doing whatever they can to help you think more fiber. With that, I thank you all for your attention today, and I'm assuming we have to go to questions next.
Thank you, Mike. We will now begin the question and answer session. If you have a question, please press 0, then 1 on your touch-tone phone. If you wish to be removed from the queue, please press 0, then 2. If you're using a speakerphone, you may need to pick up the handset first before pressing the numbers. Once again, if there are any questions, please press 0, then 1 on your touch-tone phone. Standing by for audio questions. Once again, that's 0, then 1 on your touch-tone phone. We have no further questions at this time.
Very good. Thank you, Richard.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating. You may now disconnect. Speakers, please stand by for your post-conference.